which existing rail bridges on the branch line are adequate for their in their current situation, or need strengthening or repairs, or need replacement. Each bridge is going to be evaluated for the following. First is condition, and we will talk about that in the next slides. Second is capacity, which we'll talk about in the design loading assumptions, as well as functionality. And in support of these evaluations, rail bridge inspections were completed in February as a first step in the process. The purpose of these inspections were to verify the conditions of the existing bridges from previous inspection reports, as well as to assess the conditions and obtain adequate information for performing the further assessments. Next slide. So on your slides are, I'm going to have two slides here of just typical bridges that we might find on the rail line. These are not bridges on our actual rail line, except for I think one of them, but they are typical bridges that we do have. So first, just to get you guys framed, the one on the left is the deck plate girder. On the top right is a through plate girder where the rail line, or the rails sit lower. And then we have a steel truss bridge. Next slide. And then we have concrete bridges. The one on the left is actually the Capitola concrete bridge on the eastern side of Capitola. And then we have several timber trestles. This is not one of our timber trestles, but just typical of what we might find on the rail line. Next slide. First, we completed the inspections in February. Steel spans, if we did not already have them scheduled for replacement for various reasons, were inspected to gather enough information to perform structural ratings. Concrete span bridges were visually inspected to assess the current conditions and to assure that there are no immediate structural issues that we were not aware of. And then timber bridges and steel trusses were inspected on a cursory level. And the inspection results feed into the infrastructure evaluation. When we switch to the next slide, Peter Graff and Mark McLaren from HDR will be with us here via Zoom to provide a summary of the preliminary results from the evaluations, as well as to discuss the design loadings and some design loading assumptions that we have from the project team. Slide. Yeah.
All right, thank you, Riley. Can you hear me? I want to make sure. Okay, great. So here's the structures inventory table, which is also included as attachment 2 to the staff report. And it shows the approach for replacing and repairing bridges that are suitable for passenger rail service. This is based on condition currently. The majority of the existing bridges need to be replaced in order to accommodate passenger rail service. This includes 16 timber bridges, 5 steel girder bridges, 1 steel truss bridge, and 1 wrought iron truss bridge are preliminarily recommended for replacement due to the level of existing deterioration and significant level of rehab that would be required to meet operational and maintenance needs. There's 2 steel bridges over Highway 1 in Aptos that will be replaced as part of the auxiliary lanes, bus on shoulder, and coastal rail trail segment 12 of the project. The remaining bridges that require further analysis to determine whether capacity and functionality meet the needs of passenger rail service. For these bridges, the project team is in the process of developing load ratings in order to understand their available capacity. Load rating a railroad bridge is a procedure in the industry used to evaluate and understand the load carrying capacity of a bridge. And the resulting load rating can be compared to the anticipated loadings to determine whether the bridge can safely carry the loads, or whether it needs to be strengthened or repaired, or if it's substantially under capacity, it could need replacement. Currently, with these bridge capacity assessments, functionality will also be considered. Functionality considers the existing bridge with respect to other surrounding facilities, and with the future rail or road alignments. The bridges need to be, the remaining bridges need to be evaluated for roadway vertical clearance, horizontal clearance, and whether alignment adjustments are needed for the passenger rail facility. For example, in the county of Santa Cruz, they've requested the project lengthen the rail bridge spans over Soquel Drive in order to provide for future bike lanes and sidewalks. Next slide. So this slide depicts some of the design loadings that could be considered. The industry standard for freight rail is Cooper 80 live load, and that's shown in the diagram there. It has a number of closely spaced 80 kip or 80,000 pound, I should say, axles that typically govern freight bridge design, as well as a lot of traditional passenger rail designs. The loading effects, and you can see there's two different pictures there. One shows a diesel freight locomotive, and another shows a multiple unit passenger train. This typically varies. The effects of this Cooper 80 live load varies based on span length and span type. With span length, typically shorter spans, you have, say, one axle on a span, and it produces a fairly high effect from that single axle. But as you get into longer spans, then you have many of those heavy axles applied to a long span, and the load effects can vary compared to this live load diagram, the effects of the live load diagram. Freight trains are typically considerably heavier, and traditional passenger locomotives can be considerably heavy as well, talking about that axle load on a short span. But for passenger trains, for longer spans, the effects typically become less. So at this point, designing for Cooper 80 live load preserves the ability to carry freight trains and traditional passenger trains. If we were to consider any lower standard, a loading standard, the cost savings would probably be minimal, maybe 5 to 10% per bridge, as materials are only 30% of the total cost of a bridge itself. So you're not saving a lot, say, by going to E60 from an E80. And for existing bridges, in order to reduce project costs and maximize number of bridges that can remain, we're going to develop maximum bridge loading demands for comparison with the calculated rating capacity, so we can see if those existing structures can be maintained where applicable. By using Cooper 80 live load, this would preserve the ability to align with the California State Rail Plan and maintain a connected state network to the state rail system, and provide potentially coordinated intercity rail services. And this is important for a more competitive state and federal funding. So at this point, our recommendation is for any new structures, any bridges that need to be replaced, we recommend that they be designed for Cooper 80 live load for freight and passenger loading. For existing bridges, to ensure the existing capacity is adequate, we recommend that these existing structures be maintained or strengthened to meet freight and passenger demands. Next slide. So this slide describes our next steps We're currently performing steel span ratings where we believe the condition is adequate, and we want to investigate the capacity and functionality further to see if we can keep some of the steel bridges. From there, we're going to develop a concept approach for each bridge location, whether new or existing. And we need to, of course, develop a live load criteria for the project, as discussed on the previous slide. So some of the existing, most of the timber bridges will be replaced with concrete bridges to meet current industry standards. A lot of the class 1 freights and commuter railroads have already replaced or are scheduled replacing their timber bridge inventory, as it's generally too costly and time consuming to maintain. Some of the existing taller timber, steel, and truss bridges that are on the line will be replaced with either steel deck plates, through plates, or trusses. And the configuration will be determined by the analysis and type. For repair of existing structures, we need to, as I mentioned, develop those capacity ratings and weigh with the functionality of the crossing. And for concrete bridges, we want to ensure adequate condition, capacity, and functionality. Then these will be repaired as needed and reused. So that concludes my part. I guess I will hand it back to Riley.